So far we have discussed what is the definition of quadratic equation, how many roots are there, how we can find out the roots if the equation is given, and conversely, if the roots are given, we can find out the equation also. Now, we are to find out the nature of the roots. So, we know quadratic equation is given, we can find out the two roots. Now, we can find out the nature of the roots. How? Here, four cases are there. If b square minus 4ac greater than 0, that is positive, and b square minus 4ac is a perfect square, the roots are real, rational and unequal. So, what we know, the equation is ax square plus bx plus c is equal to 0, that is the general form of a quadratic equation. B square minus 4ac, which is called discriminant. So what? B square minus 4ac, which is called discriminant, we have to calculate the discriminant, and depending upon the value of b square minus 4ac, we can find out the nature of the roots. So, if any equation is given, how we have to find out the nature? We have to first find out the discriminant, which is b square minus 4ac. Taking the first example, 3x square minus 7x plus 3 is equal to 0. Now, the question is what? Question is find out the nature of the roots. Find out the nature of the roots. Okay. So, here comparing the equation with that equation with the general form, what is A? A is 3. What is B? B is minus 7. What is C? C is 3. It is example 1. Okay. So, what we have to find out first? The discriminant, which is b square minus 4ac. So, b square minus 4ac is equal to b minus 7 whole square minus 4ac, 4 into 3 into c, 3, which is 7, 7, 49 minus 36. What is 13? So, b square minus 4ac is coming 13. Now, check these four cases. Which one is satisfying this? So, 13, it is positive, b square minus 4ac is positive, greater than 0, that is positive. Is it a perfect square? If it is a perfect square, then the roots are real, rational and unequal. But 13 is not a perfect square. So, go to the second condition. What is that? If b square minus 4 is greater than 0, it is greater than 0 positive, and it is not a perfect square, then the roots are real, irrational and unequal. So, this 13 satisfying this the second. So, the roots are, so here we will write here b square minus 4ac is equal to 13, which is greater than 0, positive, and is not a perfect square. So, the roots are what? Real, irrational and unequal. The second, real, irrational and unequal. Okay. Example second. comparing the equation this with ax square plus bx plus c is equal to 0. What is A? A is 2, B is 9, C is minus 11. Okay, what we have to calculate first? The discriminant b square minus 4ac, which is 9 square minus 4 into a into c, that is 81, minus minus plus 8 into 11, that is 88, which is 9. So, b square minus 4ac is positive, 169. Now, we have to check whether it is perfect square or not. It is clearly a perfect square. 13 whole square. 13 into 13, 39, 13. Yes, it is a perfect square. So, which one it is satisfying? The first. It is positive and it is a perfect square. The roots are real, rational and unequal. So, we will write here b square minus 4ac, which is 169 greater than 0, and it is a perfect square. So, the roots are real, rational and unequal. So, if the discriminant b square minus 4ac is positive and it is a perfect square, then it is the roots are real, rational and unequal. If it is positive but not a perfect square, it will be real. Only here is the difference. If it is a perfect square, then it will be real, rational, unequal, and if it is positive but not perfect square, it will be real, irrational and unequal. Only this is the difference, rational, irrational. So, these two conditions, I think it is much clear to you. And the third is, if b square minus 4ac is exactly equal to 0, the roots are real and equal. So, if any equation is given and you have to find out the nature of the roots, what we will do first? First, we will calculate the discriminant b square minus 4ac. If it is perfectly 0, it is exactly 0, then we will write what? The roots are real and equal. And if the discriminant less than 0, that is negative, if it is coming suppose minus 13, b square minus 4ac, suppose for any example, suppose it is coming minus 13 or minus it is, so it is negative. So, the roots are imaginary, then we will write the roots are imaginary and unequal. So, these are all about nature of the roots. Now we know how we can find out the nature of the roots, right? How we can find out? Just we have discussed. You have to find out first the discriminant, that is b square minus 4ac, and depending upon the value of b square minus 4ac, you can discuss, you can determine the nature of the roots. Now, these two questions are there for you. Please find out the roots and nature of the roots of that two equations. I can just give you the hint of the first example, that is here ax square plus bx plus c is equal to 0. The coefficient of x is not given, that means it is 0. So, find out solve that two questions and answer it in the comment box. And next problem is, if alpha and beta be the roots of the equation this, obtain the quadratic equation whose roots are this and this. This kind of problem you may face. So, read it carefully. What is the equation and these roots are given. So, first simplify that equation. Solution. Here the given equation is a into x square minus 1 plus 2bx is equal to 0. Simplifying this, it is ax square minus a plus 2bx is equal to 0. If we arrange that equation like, so it is a quadratic equation, ax square plus 2bx minus a is equal to 0, and now it is given alpha and beta, two roots of this equation. So we know the sum of the roots, that is alpha plus beta, which is minus coefficient of x by coefficient of x square. Here what is the coefficient of x? That is 2b, and s square a. So it is minus 2b by a. The product of the roots, we know alpha beta. What is that? C by a. Here the constant term minus a by a means the coefficient of x square. Here it is also a, so it is minus 1. Just remember how we can write this. If the equation is x square plus bx is equal to c is equal to 0, x square plus bx plus c is equal to 0, we know sum of the roots is minus b by a and product of the roots is c by a. We know this, from that we can write this one. Okay. Now the question is, obtain the quadratic equation whose roots are this and this. And we know if the two roots are given, what is the equation? We know equation is x square minus sum of the roots into x plus product of roots is equal to 0. So if any two roots are given, the equation will be that. So this is our question. And what are the roots? Roots are here 2 alpha plus 1 by beta and 2 beta plus 1 by alpha. So the required equation is what? X square minus sum of the roots. Sum of the roots means this plus this. So here we can write 2 alpha plus 1 by beta plus 2 beta plus 1 by alpha, and product of the roots, that is 2 alpha plus 1 by beta into 2 beta plus 1 by alpha. So we have to find out this and that with the help of this. Then we can find out the required equation. So first partly we will solve it. What is the sum of the roots? That is 2 alpha plus 1 by beta plus 2 beta plus 1 by alpha is equal to 2 into alpha plus beta plus 2 alpha plus 2 beta, 2 into alpha plus beta, and we can write it is 1 by alpha plus 1 by beta. Is that clear to you? 2 alpha plus 2 beta, that is 2 into alpha plus beta, and 1 by alpha plus 1 by beta. So solving it, alpha beta, that is alpha plus beta, and it is 2 alpha plus beta. So here alpha plus beta, we know it is minus 2b by a. Here alpha beta, we know it is minus 1. Put the value here, that is 2 into minus 2b by a plus minus 2b by a by minus 1. So minus minus plus. So if we also take as comment minus 2b by a, it will be, or it is minus 4b by a minus minus plus 2b by a. So 2b by a, or minus 4b plus 2b, it is minus 2b by a. So the sum of the roots are minus 2b by a. Now we will find out the product of the roots. So what is the product of the roots? Product of the roots is 2 alpha plus 1 by beta into 2 beta plus 1 by alpha. So it is what? 4 alpha beta plus 2 alpha by alpha plus 2 beta into 1 by beta plus 1 by alpha beta. So which is 4 alpha beta plus 2 plus 2 plus 1 by alpha beta, which is 4 alpha beta plus 4 plus 1 by alpha beta. And we know the value of alpha beta, it is minus 1. So 4 into minus 1, the value of alpha beta, plus 4 plus the value of alpha beta minus 1. So it is minus 4 plus 4 minus 1. So it is minus 1. So the sum of the roots is minus 2b by a and the product of the roots is minus 1. Just put in the required equation. What is the required equation? The required equation is x square minus sum of the roots, that is minus 2b by a into x, plus product of the roots, that is minus 1, is equal to 0, which is x square minus minus plus 2b by a into x minus 1 is equal to 0. Or simplifying, we can write ax square plus 2bx minus a is equal to 0, which is the answer. Ax square plus 2bx minus a is equal to 0.